So if I've drawn an ellipse and I've labeled all these parts here, like I said, this middle point here, the center, right? This is our center point. So label that HK. If I've chosen these letters to represent the various distances that are listed on here, then it would make sense that that would be the distance of this dotted line here, square root of b squared plus c squared. And so thinking about this, I drew this hoping that the standard equation then would make a little more sense to you guys why it's what it is. So with the standard equation of an ellipse with the center at HK, those of you joining us on the video, I understand you missed the drawing at the beginning. I just drew an ellipse and labeled some stuff, and now we're doing the standard equation of an ellipse from section 9.2. So with the center at HK and major and minor axes of lengths 2a and 2b, respectively. And what does that mean if we consider this, right? This is our major axis. So the major axis is always going to be the axis that matches the longest length if you were to draw a line through the middle of the ellipse, okay? And this is our minor axis here, right? That's a dotted line across the smaller section of our ellipse that runs through the center. So, is it clear from my drawing that the length of the major axis is 2a? Does that make sense to everybody? I labeled this as A, so it would be 2a. And since this distance here is b, then the length of my minor axis would be 2b, right? Where 0 is less than b is less than a. So just to be clear, the distance, both of these distances are greater than 0, but b is smaller than a, is all that last statement's saying, right? Our minor axis will always be smaller than our major axis. If the length of those axes were the same, we wouldn't have an ellipse. What would we have? We'd have a circle, right? So this has to be true in order for it to be an ellipse. And here's our two equations. X minus h squared over a squared plus y minus k squared over b squared equals 1. And this is the equation when the major axis is horizontal. So when it looks like our ellipse here looks, but of course this thing could be rotated 90 degrees and our major axis run vertical. So we have to have a different equation for when it's vertical. That's going to be x minus h squared over b squared. We just flip the location of the a squared and the b squared. Y minus k squared over a squared equals 1. And this is major axis. It's vertical. Now, we have, similar to what we had with a parabola. We had this focus, which was a point inside the parabola that was p units from the vertex. We have a focus here inside our ellipse, and we have a focus here. The plural of focus is foci, at least in math, all right? No relation to foci. They're not distant cousins. No relation to Loki. Sorry, they're not distant. I blew my Marvel joke. I was trying to make that. Anyway, it's not even spelled the same. So the foci are on the major axis. C units from center. with, and they match this equation here, c squared equals a squared minus b squared. Looks pretty close to the Pythagorean theorem except for that minus in the middle there. So the focus on each side of the center point, the foci, right, will be c units. This is c, and this is c. All right, we've labeled it down here. I'm not going to put that c there because I don't want to confuse you with the hk. But they will, just like we had in our parabola where the focus was p units, in this drawing, the foci are c units on each side of hk. All right? And again, if this thing was oriented, if it was flipped 90 degrees, then it would be the same kind of drawing. C would be a distance that runs up here, right, instead of runs horizontally. Now, just like we did with the other equations, if the center is at the origin, at 0, 0, then note that the equations would be x squared over a squared plus y squared over b squared equals 1, right? Horizontal, major axis. And then x squared over b squared plus y squared over a squared equals 1 if it's got a vertical major axis. All right, let's finish writing that down. So this is interesting with our equation for the foci, as far as the distance. That distance is found as c squared equals a squared minus b squared, right? So if this is c, and this distance here is b, then that means that this distance here has got to be a. Does everybody see that? If this is a right triangle, in order for c squared to be equal to a squared minus b squared, this distance here has to also be a. So the distance of this line, as it goes from the one of the foci to this point xy out here that runs through the center, is the same as that distance there. That's just something that's sort of obvious through observation as you consider that diagram. All right. But let's just see if we can do some examples using this equation now that we have that. Any questions, though, about what I've written down? Does everything make sense? It's a lot of information, but does it make sense? All right? So the example 1 says, find the standard form of the equation of the ellipse having foci at 0, 1, and 4, 1. So we have foci at 0, 1 and foci at 4, 1. And a major axis of length 6. All right? If our major axis has a length of 6, how does that relate to these variables that we have in here? Which variables have to do with the major axis, the length of the major axis in our definition here? A does, right? Because we said the length of the major axis is 2a. Mm-hmm. So we can say then that 2a equals 6. So we see that? Mm-hmm. And okay, so they just give us a drawing over there, right? Yes.
Is C always half of A, or is it just half of A in that example?
Is C always half of A?
Yeah, or is it just that?
No, it's going to be. You got to relate it like this, right? So it's not necessarily half of A. It's got to be located in a place so that this distance here, like we said a minute ago, matches that distance there. All right, but this should give us enough information to hopefully figure this out, right? So they've given us a drawing. If 2a equals 6, then we know that this distance here with the foci, the distance of the foci from the center is going to be 3. No, wait a minute. That's the whole thing. My bad. So a equals 3. So this whole distance here equals 3. And they do show you that when they've got that graph for you there, that the center point, the point that's halfway between this, center has to be equal to 2, 1.
It has to.
Yeah. Because
So would you just take the first one divided by 2?
I would just, yeah, the y stays the same. So because the y is the same, then we know that the major axis is going to be horizontal. Does everybody see that?
Yes.
And yeah, the point here it will always be half the distance because the foci is the same distance on each side, right? So it's got to be halfway between those. So 4 minus 0 divided by 2 is going to give us a distance of 2, right? That's 4 minus 0 divided by 2 equals 2. So we've got our center point. So we've got H and K. We've got A. So the only thing that we don't have at this point is B, right?
And C? Or do we have C?
No, we don't need C. Right?
So they said by the midpoint formula, if the center of the ellipse is 2, 1, and the distance from the center to one of the foci is 2, then we know that A equals 3. We said that already. And so then we have an equation over here that tells us the relationship between C and A and B, right? Remember, C is our distance here. So what is C in our particular problem? C is the distance from the foci to the center.
Yes. So would you just do the distance formula?
We calculated that to be, that's where they did the midpoint to find what the point is. And so if we've got a foci at 0 on this line 1, a center at 2, and another foci at 4, then C has to be 2, right? So C equals 2, and so we would use our formula C squared equals A squared minus B squared to say that 2 squared equals 3 squared minus B squared, or 4 equals 9 minus B squared, 4 equals 9 minus B squared, so that's negative 5 on both sides, so B squared equals 5, and B equals the square root of 5. Does everybody see how I got that?
Oh, wait, why do we know C is 2 again?
We know C is 2 because
this is the distance from
this is the
point
distance
to
from the
center.
foci to the center,
Oh, yeah. Okay.
right? And we've got all of that information right here. It's really easy to see from this one. All right, so now we should be able to write our equation, right? Which equation are we using? The top one or the bottom one?
The
The
one.
top one.
Because the
Because
major
it's
axis is
it's horizontal.
Because
it's
the
not
major axis is horizontal. How do we know that?
because of the 2 points, because the y axis.
Because the y value is the same, right, for both of those, exactly. So we're going to use this equation here. We're going to use x minus h
Well, no, if the x is the same.
squared
Well, yeah. The axis.
over a squared plus y minus k squared over b squared equals 1. So we're just going to plug in our values for that. So it would be x minus, this is our center, h and k is our center, so 2 squared over a squared, we have a as 3, so 3 squared is going to be 9 plus y minus k, our center point is, y value is 1, so y minus 1 squared over our b is square root of 5, so when we square that we get 5, and all of that equals 1. So this would be our equation for our.
Why is it 2? Because in the definition it says 2a and 2b. When would you use 2B?
If it was vertical, wouldn't you use 2b if it was vertical?
Well, no, because A still represents the distance on the major axis, right? So it just depends on how they constructed the problem, right? It's possible they could have given us the problem in such a way that let us know what this point was here. Maybe they would have given us B and then we had to calculate C instead. So,
Okay.
right, if they'd given us information to get this distance, then we would have found B and we could have then used this equation here to find A.
So how would we know to use A on this one?
We know to use A because A is the distance. A is basically half the length of our major axis inside the ellipse. And the problem told us that the major axis has a length of 6.
Yes.
All right, and so the 2A corresponds to the length of the major axis. The 2B corresponds to the length of the minor axis. Okay? All right. So let's see if we can do example number 2.
We can't.
And that one says sketch the ellipse.
Oh no.
All right, but this isn't that bad.
That sounds scary.
This isn't that bad. 4x squared.
What?
I'm just going to leave our drawing up here so we can kind of refer to that. So it makes sense.
Sorry.
4x squared plus y squared equals 36.
Yes.
So now, remember in our example here, we don't have any number in front of these guys, right?
Yeah.
So we want to get rid of that, that 4 in the front there. So we're going to divide through, actually, you know what? Never mind.
No.
What we want to do is we want to make a 1. We've got to have a 1 over there on the right. So we need to divide everything by 36.
Oh,
Right?
wow.
Didn't see that coming, did you?
No, did not
Yeah,
see that
I
coming.
didn't see that
That one
coming
really
either.
threw me.
This makes sense because basically the number that we have in front of the x squared is going to turn into our a squared, right?
Yeah.
Right.
Oh, okay.
Does that make sense?
Yeah. Would you reduce it since it's 4x squared over 36? Would you reduce it so that it's 1 over 9? Or is
Yeah.
X?
Yeah, so that's what I would do for both of these guys here, right?
Whatever it
So
is.
this becomes 1.
Yep.
That equals 1. This would be,
X
like
squared.
you said, this would be x squared over 9,
Or 3 squared.
right? Well, yeah, we'll do that in just a second. This is going to be y, so we'll just keep this as y squared over 36.
Yeah.
And so remember with our equation here, we've got these terms are squared. If we rewrite that to match our equation, we have x squared over 3 squared plus, they conveniently gave us numbers that were perfect squares, right?
Would
Well,
you
but-
imagine that?
How easy is that, right?
That's not gonna happen.
So what's our h and k for this one?
Our H and K is 0, 0.
0,
0,
Because,
0, right?
No.
I heard you, Diego.
Yes, you got it.
I said it.
So
You're worthless.
So we've got a center right here, 0, 0. The A distance is 3 squared. So the A is 3. Sorry, A is 3. B is 6. So which way is this ellipse oriented? Vertically or
Ooh.
which way's the long side?
Vertically.
It runs
Wait, I forgot how
vertically,
we do
right?
this again.
So
How do
so
we do
this if 6 is our full distance here, then we've got a point up here and we've got a point down here.
Oh, yeah.
That both of those are going to be a distance
Oh,
of
'cause it
3.
says the same.
You guys see how that would have to be 3,
Yes.
right? So we got like 1. Why did I do that? 1 like that.
It's because
Okay.
this number is bigger. Because 6 whatever.
Oh.
That's another way to do it.
And so this
that's
one
how you know
here,
it's going.
um,
Oh, okay, yeah.
I said B had to be a distance of 3, but B has to be a distance of 6,
Yep.
right?
Come on, let's roll.
Maybe he's throwing it along, okay.
No, it's
He's
fine.
trying.
B? Hey, he knows it better than I do.
Hey.
Hey,
Everyone does it better than you.
that's a B. Okay.
Diego.
I'm just grabbing these values from the formula, right? So this distance here has to be 6,
What the heck? That's
and then the distance for the B has to be 3. So these go to here.
Yes.
how much happens.
There we go. And so now we should be able to draw our ellipsis, right?
Picture my lips. Boom. That's not
All right. Does everybody able to see how we were able to get that?
Yes.
Did I lose anybody since I said A instead of B or something, vice
Wait, so
versa.
how'd you know it was vertical?
I knew it was vertical because the
6 was
distance
bigger.
says this 6 is bigger than this 3.
You're gonna know it's gonna go up because when you put your points, it's gonna go all the way to 6, and then for x, it's only gonna go to 3.
Yeah, so this is actually A. I was looking at my equation for when it's horizontal. That's why I said the wrong thing, right?
Yes.
It's this one here because what does it say right here? A has to always be bigger than B, right? So our A in this one has to be the 6, and our B in this one has to be the 3. And so if A is under the Y, like in this one here, then we have to have a vertical major axis, right?
How do you know that A is over Y?
How do I know? Because of this right here. The bigger number,
Is the A.
the 6 is the A. See?
What is it?
Because the equation that this matches is x squared on the bottom down there. If our h and our k are 0, 0. This matches x squared over b squared plus y squared over a squared equals 1. How do we know that? Because 6 is bigger than 3.
And that's all we do.
This has to always be the bigger number. A has to be the bigger number.
It's easy.
Does that make sense?
Yes.
So once we get it in the correct form, we look and see is the bigger number under the y or the x. And if the bigger number is under the y, then it's going to have a vertical major axis. If it's under the x, it's going to have a horizontal major axis. Okay? You can plot this on a calculator. And so they show you how to do that. You would basically, it's like we did before, you have to do it as 2 separate equations. So you can check your work that way by just solving for y. And you'll have a plus and minus, values. 36 minus 4x squared, the square root of that, positive and the negative square root of that will give you what the equation looks like. All right, any questions about this?
No.
No.
I'm trying my best to get you guys out of here, but I don't know if it's going to happen
Easy, easy.
early because I want to do two more examples.
You just go through the examples really fast.
Huh?
You just go through the examples really fast.
We'll see. I got to make sure you guys understand.
I
Right?
don't understand.
We understand.
I understand
We should
it.
just be able to.
Diego's the only one who's trying to worry about.
Oh, I don't know. Stephen Stephen asked me a question. I think about the A or something, right?
Yeah, we understand it now.
You got it now? Okay.
Now.
All right. So now that this happened. Now, what if I gave you this problem? All right. So I gave you.
Are you okay? You're okay?
I didn't realize that was circle.
So this is our major. Let's make a little room here.
Wait, are we doing example 3?
Huh?
Doing example 3?
Yeah, we're doing example 3 now. So we've got an ellipse
I don't like that.
given by this equation,
I don't like
x squared plus 4y squared. This is good because this will give Hayden another
Oh yeah. You
opportunity to practice his completing the square.
He needs
that. I
it.
completed the square on the quiz today. I mean,
You did. That's right. We want it to stick with you, right? The more problems you do, the better that it'll stick with you. So it says, they actually want us to graph this ellipse. But in order to graph it, we're going to have to first put it in the standard form, right? So let's group all of our x squared terms together.
So it's x squared plus 6x plus 9 plus 9.
I'm going to move my 9. Go ahead and move my 9 over to
and
here.
then you take this, and then you take 6 divided by 2
And
is
then
3.
it's 4y squared
The fit.
minus 8.
Okay, wait.
The first
I'm hearing too much talking. Let's do this one first.
X
Half of
squared
6 is
3,
3
so it's
squared
x
is
squared
9.
plus
3
6.
squared is 9.
Yes, 9.
So that's our
No,
first
just
one.
answering these questions. You're making it way too
Right.
complicated.
This one here, we're going to have to pull this 4 out. So I added a 9 here, so I'm going to have to add a 9 over here.
Yes.
All right, don't forget to do that. That's important. I'm realizing that I'm running out of room, so hang on a second. Let's do x squared plus 6x plus 9. All right, so then we're going to do the plus, this is the 4y squared and the minus 8, but we're going to have to pull
Couldn't
this
you-
4 out.
Okay, that's what I was gonna ask.
All
How do you
right.
do that?
So let's pull this 4 out, we get y squared minus 2y,
Plus 1.
so plus 1, right? Plus 1. And so what do I have to add over here to this side?
Plus
1.
4.
A 4. You have to remember the 4 is in, who said 4?
Aiden.
Oh, okay.
You sounded so disappointed.
You sounded so disappointed.
You're like, oh.
I thought you were already on the board. I thought you were on the board, and I thought it came from over here. I was like, okay, cool. Someone else is going to get on the board. But yeah, you're not on the board, so good job. So, I'm very excited for you.
He's just so used to me being having questions.
So yeah, we're going to add a 4 over there. So now, let's take the, this will be x plus 3 squared, right? All of that over 1 squared, right? You can put it over 1 squared, that won't change the value of that. This is going to be plus, on the top here we've got a y minus 1 squared, right? And if we take this and we put it on the bottom, then this has to be a 1/4 on the bottom,
Yes.
right? But we want it to be squared, so it's going to be a 1/2 squared. Does everybody see that?
No.
But doesn't it have to equal 1 on that
Yeah,
side?
it
Because
has
it
to
doesn't
equal
equal
1
1.
on that
Oh, you're right. You're right. Okay,
So
I'm
don't we have to
dividing
move
here.
the 4
I
over
missed
there?
that. I missed that. So give me a
Yeah.
second. So you're right. This is going to be 4. So let's not do too much at once. All right,
Yeah.
Let's do this. There.
It's
Okay.
not 1 squared on the bottom, it should be 2 squared.
Huh?
It should be 2
He's looking
squared,
at
right?
the book. He doesn't know that.
I'm about to divide everything by 4, right? So I have to
Do you have
divide
to do
everything by 4.
everything?
Mm-hmm.
Yeah, if I get this a 1,
You
so
have to
let's
get
just
one
leave
of
this
those.
alone for right now.
Okay.
Let's just leave that like that, all right? I jumped the gun a little bit. So we're going to divide everything by 4 in order to get a 1 there. Does everybody see that?
Yes.
Now we have x plus 3 squared over 2 squared
Mm-hmm.
plus this 4 and this 4 cancels out. So now we've got y minus 1 squared over 1 squared equals 1. Now we're in standard form. All right. So that being said, I'm not going to actually plot it, but we can see that the h and the k are going to be equal to what?
3, 1.
Negative 3.
3, 1.
Negative 3
1.
and 1, right? I saw Stephen get that one.
Yes.
Steven.
There you go.
And what is our a? A equals what?
A equals
The bigger number,
2.
right? A equals 2, B equals 1,
Yes.
right? Isn't that enough information for us to graph it then?
Yes.
Once we get that, we can graph it,
Yes.
right?
Alright.
All right, so last problem. Any questions about that?
Wait, so A just equals whatever the bigger number is? It doesn't matter where it's at?
Well, I mean, it matters where it's at.
Well, we do
because
have to know which way to orient the graph, right?
Yeah.
Whatever the bigger number is, that's going to be A. So if it's under the Y,
So yeah, it
it's
doesn't
going to be
matter.
vertical.
So yeah,
you
so
really
the
don't know
X
which
should
one
be
you're
horizontal.
using until you get the numbers.
Yeah, I should have told you though. Is this going to have a major axis that's horizontal or vertical?
Horizontal.
It's horizontal because the A, the
It's
bigger
big.
number,
Is under the
is
X.
under the X. That's how we know it's horizontal. All right.
Oh, okay, yeah.
All right. Example 4
This
is the same, but because of the values of A and B, you can tell the major axis is vertical. So
I know.
I'm not even going to do 4.
Yeah.
4 works out to be exactly the same way.
Exactly.
You get a square root that gets stuck in there, right? When you're figuring out what C is. So this is something important. Did they do that? Did they figure out C on the other one? They didn't really do that. Why did they figure out C on this one? Did it ask you to put the focus? Yes.
Yeah.
So this one says find the foci of the ellipse. All right. And so once you figure out A and B, does everybody see that you can
Yes,
figure out
you got
C?
C, because A squared minus B squared equals C squared.
This equation,
Right there at the bottom.
Where?
Middle,
Right
right
there.
there.
Right. This equation lets you find C, which is the distance between the center point and the
And the
focus. All right. So that's something to make sure that you guys understand how to do. You'll have some problems to. Some problems to give you some examples of that. But you just basically need to know this definition, right, and be able to make sense of this definition. So this needs to be on note cards, right?
That whole thing.
All right, hey, we're out of here early. You guys go. Go get some lunch.
You did it in less than 30 minutes, too.
I did. I just did that last one.
Oh, yeah.
That's all right. You guys will forgive me for that if I let you go early.